Okay, the SOAR distribution shown in the table is for all students who took a yearly AP Statistics exam. An AP Statistics teacher had 49 students preparing to take the exam. Though they were obviously not random, his sample, he considered his students to be typical of all the national students. What's the probability that his students will achieve an average score of at least a 3? Okay, so what we need to do is get a mean and a standard deviation for this probability model, and then a sampling distribution model of 49 students over and over again would be normally distributed with the same mean as this probability model, but it would have a standard deviation equal to this model standard deviation divided by the square root of 49. That's what the central limit theorem tells us. And then once we know that, figuring out the probability that his students will achieve a score of at least a 3 is just going to be a norm.dist question. So first thing we'll do is copy the data to the table in Excel. And let me pull up my Excel. So I'm going to just, this was in here from before, I'll just clear that out. Okay, and I'm going to paste it into there. Whoops, sorry, things are jumping all over the place. Okay, and I need to get the probability. So the probability of the given value, the probability of the given score is equal to the percent. So I'll come in here, we'll say just equal to the percent divided by 100, because we don't want it to be in terms of percent. We want to know the probability that you made a 5. Okay, and so then the score x times the probability of x is what we'll use to get the mean. So that's just going to be equal to the score times the probability of the score. We'll do that for each of the scores, and the sum of that column is going to be our mean. So the mean is equal to the sum of this column right here. So that's your, what we can expect. The average score is 2.891. So to get the standard deviation, we're going to do x minus the mean and square it. That's just your deviation. And then we're going to take that and multiply it by the probability. So you're going to do x minus m squared times the probability of x as your last column. And you sum that, and then it's the square root of that sum will be your standard deviation for the entire distribution. Okay, so you do x, which is right here, so this is going to be equals, and then it's going to be parenthesis, the x minus the mean, which is going to be an absolute reference, so we'll put an F4 on that, and we're going to square that, and we're going to fill that all the way down. Then we're going to take that cell that we just calculated and multiply it by its corresponding probability, which is E, and hit enter. And then we come down and fill that in. So the standard deviation for the whole model is going to be equal to the square root of the sum, which is going to be this one right here, of this column right here. And this is all familiar from the last unit. All right, so the standard deviation of your model is going to be this divided by the square root of 49. So finally, you want to know norm.dist, the probability that you got greater than a 3. So, and actually you're going to have to do 1 minus this, because to get the area to the right. So 1 minus norm.dist, and then in here we're going to put 3, comma the mean, which is this number, comma the standard deviation, which is this number divided by the square root of the sample size, which is 49, and then comma 1 in the close parenthesis, and then equals. So there's a 0.285 or 28.5% chance that his students did better than that. So I have to do 4 decimal places. So 0.2854. Okay.